So at first today we will discuss about the difference between strata and clusters. Okay, so what is strata and what is cluster? So strata and clusters both are non-overlapping subsets of the populations. They differ in several ways. All strata are represented in the sample, but only a subset of cluster are in the sample. So strata means what? Strata means in that strata all the samples can be there. Okay, all the values can be there. But when we are saying about cluster means what? Here we are doing the subset of the samples. So subset of clusters are in the sample. Okay, so that is the difference. That means strata can have all the datas. All that means all. Suppose we have a whole populations, and from the whole populations we are stratified the populations. But all the datas can be there. But when we are clustering the data, so some datas cannot be there. We are taking some subset of those data. Okay, so that is the thing. Just a minute, So the strata and the clusters both are non-overlapping subsets. Okay, so with stratified sampling, the best survey results occur when the elements within strata are internally homogeneous. That means we are getting the same type of data. Okay, so that is the best survey results when the data's quality, data's categories are same. But with cluster sampling, the best results occur when elements within the clusters are internally heterogeneous. Okay, so in that clusters we have heterogeneous data also. So when in strata, when the data are homogeneous, that is the best survey results, and in case of cluster sampling, when we have heterogeneous data, that is the best sampling. We are getting the best results. So these are the difference between strata and clusters. So now we will discuss about multi-stage sampling. So multi-stage, okay, that means the sampling can be done with different stages, different steps can be there. So this is the complex form of cluster sampling. So obviously this is very complex form because we need to take the samples of the populations with different stages, different levels are there. Okay, so in which two or more levels of units are embedded on one in the other. So first stage we will do some random number of districts chosen in all states. Suppose we are getting the project that we have to sample the states. So at first we will sample the districts of states. So at first we will take the random numbers of districts chosen in all states are there, and we will choose the random number of districts from that, and followed by this random number of then we should choose some taluks or villages. So under this district some villages can be there, some taluks can be there, so we can choose that. And thirdly we can choose some houses, we will select some houses. So that means we are taking the broad area. Okay, that is we are choosing randomly some district, and inside the district how many villages are there or how many taluks are there, we need to choose that randomly, and after that we need to choose the houses. Okay, so all ultimate units, houses for instance selected at last step are surveyed. So actually we need to survey for the means we need to select the houses, and we need to take the informations from the persons who are present inside the house. Okay, so we should take the informations from them. So ultimately our purpose is that, but before that we are sampling the districts, and after district sampling we will sample the villages or taluks, then we can go for the houses. Okay, so these are the multiple stage sampling. So different stages are there. So this technique is essentially the process of taking random samples of preceding random samples of preceding random samples. That means we are taking some random samples and again we are doing the random samples on those random samples also. Okay, so that is sample of samples, right? So that's why this is called multi-stage. So not as effective as true random sample, but probably solves more of the problems inherent to random samples. So it can solve different types of problems of random samples, and an effective strategy because it banks on multiple randomizations. Okay, so it is extremely useful. So here we are doing multiple multi-stage sampling. So we are sampling the data again and again. So that means we are getting the perfect data what we need. And multi-stage sampling used frequently when a complete list of all members of the populations not exist and is inappropriate. Okay, so this sampling it can use frequently, and the complete list of all members of the populations not exist here because we are sampling again and again. So it may be sometimes inappropriate also. So by avoiding the use of all sample units in all selected clusters, multi-stage sampling avoids the large and perhaps the unnecessary cost associated with traditional clustering sampling. So this is the advantage of multi-stage sampling. So here we can avoid the large and unnecessary datas. Okay, and this is the if we can avoid different unnecessary data, so it is obviously cost effective. So different so we can do our sample in our budget. Okay, so it is a low budget sampling because we can cost the budgets, we can cost the sampling cost of the huge data, because here we are reducing so many values, so many datas. Okay, so it is the advantage of multi-stage sampling over cluster sampling. So another point is part of the information is collected from whole sample and part of the subsamples. So here this is actually multi-phase. So in multi-phase, where we can collect the whole sample, informations from the whole sample and also from part of the subsample. Okay, so we are getting the data from different phases. At phase 1 we are getting suppose the whole sample. At phase 2 we are getting the different we are just a subsample of we are getting the subsample of the whole sample. Okay, and this is multi-stage. Okay, so these are the, you have to remember the difference between these different types of sample, that multi-stage and multi-phase. Okay, cluster sampling, what are the differences between these? So here we have suppose we are doing some survey. Okay, and here we are doing some suppose medical survey. So here we are doing at the phase 1 we are getting some different types of access. Suppose this is a TB survey and this is MT surveys, and we are X-ray chest in MT plus this is the positive cases. Okay, in the phase 2 we are getting these values, the positive values, the X-ray reports of the positive X-ray reports, and then sputum examinations is X-ray. These are the positive cases. So that means suppose this is actually the medical survey. So here we have the the lots of data, lots of criteria for a patient, and we at the phase 1 we need to take some different criteria, and the phase 2 just we need to take again from that criteria we need to just resample those data. So, we need to take only the positive cases, and here also we need to cases the sputum examinations we need to cases the positive cases. So, different phase we need to sample the data into different phases. Okay. And survey by such procedure is less costly, less laborious, and more purposeful. Okay. So, this is also very important sampling technique, because this is also less costly sampling technique, and this is less laborious. You can do it without much more effort and more purposeful, and it can solve your purpose very clearly. That means the actual data, the perfect data you can get from the whole sample, from the whole data, whole population. Okay. So, another sampling technique, that is matched random sampling. So, matched random sampling is what? Here a method of assigning participants to groups in which pairs of participants are first matched on some characteristics and then individually assigned randomly to groups. So, that means there are some criteria. In matched random sampling means here we have some criteria, we have some conditions. If the persons of the participants are matched with that means criteria, then they are selected. Okay. And the procedure for matched random sampling can be briefed with following contexts. So, here two samples in which the members are clearly paired or they are matched explicitly by the researcher. Okay. For example, you can say IQ measurement of pairs of identical twins. Okay. So, two samples in which the members are clearly paired. So, if you are just measured the IQ of the twins, so that is the you are taking the samples from the paired. Okay. And those samples in which the same attribute or variable is measured twice on each subject under different circumstances, commonly called repeated measures. Okay. So, in matched random samples, you need to know, you need to do the samples on some identical pair, or you need to do the samples in which the same attribute or variable, you can do that on some same variables or attribute, and this is measured twice on each subject. So, that is repeated measures. Okay. But the circumstances are different circumstances. Okay. The surroundings are different, but the pairs are same. Okay. So, this is called repeated measures. So, this is the example. Here the example includes the times of group of athletes for 1500 meter before and after the week of special training, the milk yields of cows before and after being fed a particular diet. So, that means we are selecting a group. Okay. Before means before training and after training. Okay. So, this type of things means before training there are, you can select some athletes, and after providing the training and after training means there are lots of means effort, and this lots of things can be there, and after that you are getting those persons. Okay. And this is also examples of means matched random sampling. And another things, suppose another example is milk yields of cows before and after being fed a particular diet. So, means when you are getting the milk from the cows before diet and after diet, you are getting, you can get the variations. So, the situations is different, but your sample value is same, your means your populations is same, but the circumstances are different. Okay. So, you are providing the training, before training you are getting some athletes, and from that athletes you are selecting some athletes. Okay. After training. Okay. So, that means your assets are same, but the surroundings are different. Okay. So, this is called, this is the example, these are the example of matched random sampling. So, this is the another sampling technique. This is quota sampling. The populations is first segmented into mutually exclusive subgroups, just as in stratified sampling. So, we have to just divided the whole populations into different segment, and then judgment used to select subjects or units from each segment based on specified proportions. So now you have to just segmented, you have to just justified the peoples from those segments, and using some specific criteria. Suppose for example, an interviewer may be told to sample 200 females and 300 males. So here these examples are very important. For each and every samples you have to remember the examples also, because and here the situations can be given to you, and it can ask that tell what sampling technique we will follow. Okay, so follow the examples properly. So an interviewer may be told to the sample 200 females and 300 males between the age of 45 and 60. So here this is the example. Suppose we want to categorize our our populations according to some technique, and at first you are dividing the whole populations using the female and male criteria, and after that you are providing the age criteria also. So it is the second step which makes the technique one of non-probability sampling. The quota sampling, the selections of the sample is non-random. Okay, here you are not choosing the data randomly, you are actually choosing you are selecting some data, you are selective, you are selecting some persons intentionally. Okay, so interviewer might be tempted to interview those who look most helpful. Okay, so you can select those one. The problem is that these samples may be biased. Yes, because a person is, suppose in case of interview, a person is selecting people, selecting job seeker according to their own intuitions that yes, he or she can. Okay, so sometimes their approach and should be can be much more impressive, and they can select them. Okay, but sometimes the selections can be wrong also. Okay, so this samples is biased because not everyone gets the chance of selections, because you are not selecting everyone, you are choosing someone from them. Okay, so this is bias, and that each and everyone is not getting the chance, because at first you are reducing some people from your panel. Okay, so according to the age criteria, and according to the gender, you are just selecting some peoples, and from them you are getting some peoples. Okay, so that means you are not getting everyone, you are not choosing everyone, you are selecting some peoples. So this random element is its greatest weakness, and quota versus probability has been a matter of controversy for many years. Okay, so this is the quota sampling. That means you are selecting some people from the whole things, and you are not getting the whole informations, whole populations, you are selecting something. So sometimes this type of sampling cannot be proper. Okay, so this is quota sampling. Another thing is convenience sampling. Convenience sampling is sometimes known as grab or opportunity sampling, or you can say that opportunity sampling or accidental or haphazard sampling. A type of non-probability sampling, this is also non-probability sampling, which involves the sample being drawn from that part of the populations which is close to hand, that is readily available and convenient. The researcher using such a sample cannot scientifically make generalizations about the total populations from this sample, because it would not be representative enough. Okay, so suppose for example, if the interviewer, so this example you should remember, if the interviewer was to conduct a survey at a shopping center early in the morning on a given day, the people that he or she could interview would be limited to those given there at the given time, which would not represent the views of other members of the society in such an area. If the survey was to be conducted at different times of the day and several times per week, then we will get the different result. Okay, so that means the time factor is also there. Suppose you are conducting a survey at the early morning, so some people can go for the interview and some are not. And if you are doing this this at the different times of the day, and it can repeat several times in a week, then you can get more response. So this type of sampling is most useful for pilot testing. Okay. And in social science research, snowball sampling is a similar technique where existing study subjects are used to recruit more subjects into the sample. So this is a snowball technique, snowball sampling technique, where this is actually like a convenience sampling. So this is a haphazard sampling, or you can say the opportunity sampling, okay, or accidental sampling. Okay, so this is a convenient sampling. So here you are just means okay, judgment sample purpose. Okay, so here you are just a person is going on and you don't know whether, that means that some peoples may not be there in your side. So you are asking someone, but sometimes you are not getting the response because maybe the timing is different, and according to your according to the timing you can get the response. Maybe you are not getting the whole data using this type of sampling. This is the haphazard sampling also. And another sampling technique, that is judgmental sampling or purposive sampling. Okay, so here the researchers chooses the sample based on who they think would be appropriate for the study. So judgmental sampling, you should judge that who will be the appropriate people for your research work. Okay, so this is used primarily when there is limited number of people that have expertise in that area being researched. Okay, so for that you need experienced researcher, because who can judge properly that yes, these are the set which can help in our research work, because we are getting only those data which is actually required. That means there are the number of people, that is we have a limited number of data, and in that case we need a very efficient and experienced researcher, okay, to do this type of sampling. Okay, so after that, this is the final sampling. We have a panel sampling, and this question sessions I already given to you, just in your assignment. Okay, so according to this sampling technique you should decide that situations, and you need to write down that what sampling technique we can use. So this is a large sampling method, that is panel sampling. Here the method of first selecting a group of participants through a random sampling. So this is a panel sampling, that means you are paneling. Okay, so you just select some group of participants through a random sampling method, and then asking that group for the same informations again several times over a period of time. So okay, you are just dividing the whole populations into different panels, and you are asking the people, you are surveying on those people. Okay, so therefore each participant is given same survey or interview at 2 or more time points, because you are panelizing the whole different panels are there, and you are surveying on those people. So it may happen that you are getting 2 or more times interviews, or you are doing surveys on on those persons repeatedly. Okay, so each period of data collections is called wave. So this is called wave. This sampling methodology often chosen for large scale or nationwide studies in order to get changes in the populations with regard to any number of variables, from chronic illness to job stress to weekly food expertise. These are the different type of example. That means here we are doing the sampling on a large scale of people. It can be a huge populations, and you are analyzing the population. You are dividing the whole population into different panels, and you are doing the survey on those panels again and again. Okay, you are surveying the whole thing again and again. So same people can get the chance means one or more time. So in that case, what will happen? Maybe a person is actually saying something at the first round, and maybe in the second round they can change their mind and they can provide you the different information. So it will be confusing also sometime. So panel sampling can also be used to inform researchers about within person health changes due to age or help explain changes and continuous dependent yes. So if there is any change, so we are doing the things again and again. So if there are any changes happened with these people, so they can express it again and again. So according to time durations, the situations can be changed and the informations also can change. Okay. So the suppose in medical ground, if they are in the medical field, they are doing some survey on the health conditions of the persons on the same clusters. So maybe before 1 month the health conditions will be something, and after 1 month the health conditions can be some different. So this panel sampling is very important in this type of survey. So there have been several proposed methods for analyzing panel sampling data, including growth curves. Okay, so we can just provide a graph chart also, and also this is for means we can do the survey on child also, that what is the growth rate of the child before 2 months and after 2 months, what is the growth rate of that child. So that is the we are doing the sampling again and again on the same population, same data. Okay, so this is actually called panel sampling.